Welcome to The Explainer. Today we're diving into a really fascinating journey, how the tech industry learned to stop failing so much and actually adapt to change. We're going to explore exactly how software engineering evolved from this rigid, almost factory-like assembly line into something incredibly fluid.
So, think about this for a second. How do you build a massively complex piece of software from scratch so it doesn't just completely crumble the moment you launch it? Well, if you're building a physical house, you absolutely have to lay the concrete foundation before you can even think about building the roof. There's literally zero room for error. But software is a whole different beast. It's actually a lot more like writing a book. It's this fluid, ongoing process of drafting, editing, and revising. The tech world had to figure out how to manage this really unique process, and over the years, they came up with several distinct models to do just that.
Before we look at the history, let's just make sure we're on the same page and define our terms. A software process is simply the blueprint. It's the essential set of activities that takes us from a blank screen to a fully functioning app.
Here is our roadmap for the explainer today. First, decoding the software process. 2, the rigid pioneers. 3, building in increments. 4, evolution and risk management. And finally, number 5, the agile revolution.
All right, let's kick things off with Section 1, decoding the software process.
Look, no matter how you organize your team, there are basically 4 universal activities you absolutely have to hit. First up is specification. This is that crucial stage where you define what the system actually needs to do. Make a mistake here, and you are looking at massive problems down the line. Second is development, which is where the actual production happens. Third is validation. This is where you make sure the software actually does what the customer wants, which honestly is way harder than it sounds. And finally, evolution, because software just has to keep evolving to meet changing needs. Now, every single historical model we're about to look at, they're really just different ways of organizing these exact 4 steps.
Moving right along to Section 2, the rigid pioneers.
So take a look at the strict downward flow of the classic waterfall model. It moves completely in one direction, step by step. Everything functions one after another in a strictly linear way. The rule is, when the first phase completely finishes, only then will the second phase start. So you go from requirements, to design, to testing, to operation. There is no going upstream.
But as you can probably guess, that kind of extreme rigidity comes with a massive trade-off. Now, don't get me wrong, it's great for huge, predictable 3 to 10-year projects. But what happens if you find a tiny mistake at the very end of the line? Well, because you can't go upstream, a late-stage error can literally cause the entire system to crash. The purely sequential nature just doesn't let you go back to undo or redo anything. So, to try and catch those devastating errors earlier, the industry created the V model. It actually still executes sequentially, but notice how it bends into a V shape. That's because, for every single development step down the left side, there is a dedicated matching testing phase hooked up right across from it on the right. The V model is wonderfully disciplined. It makes projects super easy to manage because every phase has its own specific deliverables. But once you hit that testing stage on the right side of the V, going backwards is an absolute nightmare. Just imagine a client suddenly changing their mind halfway through the build. In the V model, that spells total disaster. It's a pretty bad fit for complex projects where you know the functionality is going to have to adapt.
Which brings us to Section 3, building in increments.
Instead of banking everything on delivering one massive ta-da project at the very end, developers realized they needed to break things up. The incremental process model basically divides up the requirements. Version 1, Version 2, and Version 3 each act as their own standalone modules. Each of those modules goes through a mini-cycle: design, code, test, and deploy. So every subsequent release just layers on new functionality until you've got the complete system. This incremental approach is a real game changer because it finally introduces some flexibility. You can prepare the initial software fast, meaning clients get a super clear vision of the project early on. And tweaking things is way easier. However, and it's a big however, it requires a stellar team to pull off. Plus, because you're doing continuous iterations, the overall cost of the project can absolutely skyrocket over time.
Let's shift gears and look at Section 4, evolution and risk management.
You can think of the prototype model like sketching a really rough draft. You build a quick, bare-bones version just so you can ask the client, hey, is this what you meant? The entire purpose here is to quickly improve the software based on this continuous loop of client feedback long before you ever start the heavy lifting of the final implementation.
Now, clients absolutely love this. They get to see real progress immediately. But you have to beware of the ultimate trap, scope creep. That endless loop of customer feedback and constant tweaking, it can cause massive, massive delays if your team doesn't know when to finally put their foot down and say, stop.
Okay, but what if failure is simply not an option? Enter the spiral model. It combines the cyclic, repetitive nature of prototyping with the strictly planned steps of the waterfall. During each loop outward in the spiral, the team stops and performs intense risk analysis. If they spot a risk, alternate solutions are immediately evaluated and implemented before the spiral is allowed to continue.
Because it is so hyper-focused on risk management, the spiral model is phenomenal for large-scale mission-critical systems. But, much like the prototype model, that spiral can easily spin completely out of control financially. It is a highly complex, enormously costly way to develop, and it is definitely, for sure, not meant for a simple weekend project.
And that leads us right to the climax of our story, Section 5, the Agile Revolution. Agile flipped the script entirely. It basically operates on the belief that constant change isn't a problem, it's just reality. Instead of these massive multi-year timelines, tasks get divided into strict time boxes. We're talking short 2 to 3 month iterative loops designed to deliver specific features fast. It's a rapid-fire approach where a working software build is delivered after each short iteration, continually layering on features until the customer is completely satisfied.
Back in 2001, the Agile Manifesto completely shifted the entire tech industry's focus. It boldly prioritized human interactions over rigid factory-style processes. It declared that actually demoing working software is vastly superior to handing a client a giant, unreadable stack of documentation. It demanded continuous customer collaboration. And perhaps most importantly, it prioritized responding to change quickly rather than stubbornly sticking to a doomed plan.
Today, Agile is widely considered a highly realistic approach. It promotes intense teamwork and gets you that vital early delivery. But listen, Agile isn't magic. Without really strict delivery management, complex dependencies can cause total chaos. And because Agile relies on minimal documentation, a confused customer can easily steer a project entirely off a cliff if you're not careful.
So, as we wrap up, I want to leave you with a provocative thought. We've gone from the rigid, concrete steps of the old waterfall model all the way to the rapid, fluid, and ever-changing loops of Agile. But technology never actually stops. With AI and automation entering the mix today, what do you think the next great evolution of software development is going to look like? Thank you so much for joining me on this explainer. Keep learning and stay focused.